Guys, welcome to the new video again. Today we are going to discuss uh, in the previous lecture we discussed previous chapter was analysis of algorithms and time complexity. These are two topics we discussed in all the previous lectures. Alright. Now the next lecture is chapter is control abstraction and minimum and maximum problems. Alright. So these are some design strategies. These are some design strategies to minimize or maximize some output of the uh, time or space. All right. So what we see that, let's say, for this loop, all right, I is equal to I into I square. So this is, and this is I j is equal to 1 to n k plus j. So what will be the time complexity for this? So k would be what values I can get. So this is 2, and again it will be 2 to the power 2, right? And 2 to the power 2 to the power, this is 2, right? 2 to the power 3. This is how it goes, and for so 2 to the power 2 to the power k. So the number of times I will go for is log of log n, right? This I will repeat it, right? And for j it will n times, all right? But for k what values k can get, then k will be, first is 1, then 1 plus 1 2, then 3, first is n, right? N times. Then it goes how many times? It's 2, then first is 1, 3, 5, then I mean this would be n by 2 times, all right? N by 2 times. Then it will go n by 3 times, because if we uh, solve a formula for uh, in previous lectures for I plus a, it goes by n by a, all right? So for this, n by dot n by n till n by n, all right? So what, how can we solve that? Because this is n times x equal to 1 to n, 1 by x, right? So what it can become, that it is log n, we already know this is log n, so it is n log n, right? If now how can we solve this? Because whole is n by a, because this is the case we already solved, and here is uh, n log n, or this is log n, the order of this, right? This is the time complexity for this. Sorry. what is the number of times star will get print? So 1 to n. All right. So 2 to n, again fail, then 3 to n. So it would be n minus 2, I think, plus n minus 3 plus n minus 4 plus these are the things. It would be n minus 1, I forget, 1 to 3. So it would be minus 3 times plus n minus 4 times. This is the case. So it will go until what? This is n minus 1. This is 2n, right? So here 1 cut by this, right? Right. So this I2, this will become n plus 1 by 2 into n plus 1 by 2, right? This is all 2n minus 1. So we got of 1, 2, 4, 5. So what are design strategies? So these are strategies to design an efficient approach to solve a particular problem in a very efficient manner, in which it takes less time and space complexities. All right. So when the problem becomes large and complex, then divide the problem into. So first strategy is divide and conquer. Right. What is divide and conquer strategy? When the problem becomes large or complex, all right, then divide the problem into subproblems, into further subproblems, until the subproblems become really small. All right. Solve the smaller problems, combine their results if required. So this is the important case. Combine the results if required only to get the solution of the original problem. So here only we will combine the solutions only if they require. Not necessary. This is not necessary to combine all the solutions. Alright, necessary to combine all the solutions. So all the sub solutions, alright, solutions to the sub problem. Right. So in general, a problem is said to be small if it can be solved in one or two basic operations. Basic operations means that addition, subtraction, division, right? These are some basic operations. Subtractions, division, and we can say return thing. These are some basic operations. So this is called the small problem. Right? So Napoleon, what is this? Britishers divide and rule. So right, so this is some divide and rule. Eight problem given. See, this is not important select was. So yes. So in this case, this is an array, alright. So if we want to divide and sort this array, alright. So firstly, what we will do that we divide it in two parts, alright. This is a two part, half two parts of half size, alright. The size 8 then 4 this, 4 this. 6, 10, 8, 15, and 2, and this again. Again, we will divide these subproblems, right? So here the size of this subproblem is 2, also the here is 2, and this is 2, and this is 2, right? So how we can what let me see if anything happened. Right. All right. So this is the problem. All right. So this is divide and conquer. We divided it. To solve this, we will. All right. If we want to, if we want to what uh, abstract or abstract, what the synonym for abstract is find, right, the maximum from the area. All right. How we can do this? We divide it in two parts. Again, we divide. What is the maximum from this 10? What is the maximum from this 15? We merge these. We will find the maximum from these, right? We compare then these two. What is this? 15 maximum here. 6 and 12, 12. Here 18. All right. We return these, right? It goes to here. 18 is the maximum from this subproblem, right? From these, what is the maximum? This 18. So from this problem, this is 18 is the maximum, right? So this is how we do that. Algorithm for this is algorithm divide and conquer problem. If p is small p, then return sp. Alright. Else divide p into smaller instances p1, p2, pk, where k is greater than is equal to 1. Alright. Apply divide and conquer to each these problems. So this is how divide and conquer control abstraction. This is the thing, right? Approach is the problem. Divide these. Apply divide and conquer to each of these subproblems. Right? Return combined divide and conquer problem recursion. Right? Combined return is a combined combination. So algorithm divide and conquer A1 if small 1 to L, then return S small of A1 L. Right? Else M what? Divide 1 to N. S1 divide and conquer, apply divide and conquer on 1 A 1 to M, alright, which is N by 2, and S2 divide and conquer, apply divide and conquer on A M plus 1 to N, right? Then combine S1 and S2 to get the real value, right? Time complexity framework for divide and conquer problems. Let Tn represents the time complexity of divide and conquer. So Tn is equal to Fn. So if n is small, alright, Fn is order of what? Constant for constant 1, order of s, alright? Or what we can say, it could be polynomial also, right? It could be polynomial. So wait a second. Hello? हाँ हाँ बोले ऑर्डर को हाँ तो कब तक आ रहे हो so yeah, let's continue again. So order of fn here, constant here. So constant is, it will be order of 1, and for this order of what? S, this is a small subproblem. Else the for if n is large, then 2 of t n by 2 plus gn. Gn what? Gn is the some body, I think body complexity order of, so n then t n by 2 n by 2, so divide plus combine plus a small. All right, this is how it works. T of 2 t n by 2, this is a recurrence relation for what, for divide and conquer. All right, so let's solve this recurrence relation. To a divide and conquer recurrence number of sub problems. All right, this is the number of sub problems. It could be greater than 2. All right, size of each problem, it could be vary. Time for divide and combine. All right, this is my main, I said this is body complexity. All right, body of the recursion function. All right, so generalized form. P of n a dot, this is the general form for this. All right, size of sub problem, so number of sub problems, and this is the case. All right, it could be 2n by 2, tn by 2, 4n by 2. So this is not the case of for the asymmetric. So these are two type of divide and conquer problems. Symmetric, in this the we divide in equal part, the size of the problems are half of the problem. All right, and in asymmetric case, this would be this. All right, 1 by 3, 2 n by 3. So t of n by 3 plus 2 t n by 3 plus gn. So general form would be alpha n plus 1 minus alpha n of gn. This is the, yeah, gn. Or else asymmetric case would be t of n by 2 plus t of n by 4 plus gn by 2 n by 2, and then again n by 4 n by 4. So in divide and conquer strategy, divide is mandatory but combine is optional. As we said, as I said, and I just said earlier, combine is not necessary, depend on application. All right, yeah. Divide and computing time and of divide and conquer is described by recurrence relation by this. All right, this is the recurrence relation for divide and conquer. All right, so if gn if n is small and this is the otherwise. All right, n is not small. So let's discuss some problems. All right, max min problem. So produce to uh, procedure to find maximum and minimum simultaneously in an array of size n. All right. So how we can find maximum and minimum simultaneously? All right. So this is an array. All right. Comparison. We start in comparison. So what will be the non way of non divide and conquer approach would be, we we select an index or element, and then total number of comparisons made in non-decrement is 2 into n minus 1, right? In first traverse we will find what best case minus 1, worst case 2 of n minus 1, right? So average case, on an average first comparison fails for n minus 1 and plus n by 2, 3 n by 2, n by 2 of given elements, and what the hell. So the total number of comparisons, how do we do that? Let's train them. A case is 5, all right, but so non-DC max main is equal to a1 for I is equal to 2n to n. If ai is greater than max 1, max is equal to 1. Else if ai is greater than 1, minimum is equal to 1. So algebraic time complexity would be big order of n, I think. Uh, if it is in increasing order, then best case would be n minus 1, worst case 2n minus 1. So total number of comparisons would be this, and yeah, on an average, first comparison fails for 1 by 2 of given class and elements in 1 plus 1 by 2. So 3 of them is the average case. So in order, best case is n minus 1, worst case increasing order, decreasing order, average case. Worst case would be n minus 1, is 0 and minus 1. Total is right. So n minus 1, 2 of n minus 1. So worst case, time is the order of n. So if we apply divide and conquer on this, in which order of time we can solve this question? Let's start. This is the array of ours. Alright. This is a stack here. 1 to n f max and f min. Alright. 1 to n. We give the indexes only. Then for half 1 to 5 and 5 6 to 9. We call this. Alright. We find max or min from both. Alright. So we again divide this for 1 to 3 and 4 to 5. Again divide this 1 to 2 and 3 to 3, alright, because minimum is 2. So so just take a space 1 and 2 and 3 and 3, alright. What is the value of in 1 and 2, minimum and maximum? So after comparison, right, here we compared here, right. So what is the minimum here? 1 and 2, minimum is 8, maximum is 12, right, and this 0 0, right. So we combine these two, right. After combination, what is the minimum? Minimum is 0, right. Again, this is the return value of this function. We go for this, all right. This would be 4 and 5. What is 4 and 5? Minimum is minus 6 and this. So after comparison in both of these, 15 is minus 6, right. And also this is how it works for both the things. So what is the complexity of comparisons? All right, it would be number of comparison would be complexity would have a height of tree, right. So it would be log n, right. Just take a space, highest of tree, height of tree, h is equal to log n. So algorithm max min I to j max min. So a of 1 comma n is a global array, right. Parameters I and j are integers. Whatever I small, if else if when another case is small, if when a of j, else max is I of j, right. Else now divide and conquer starts. Min is equal to I plus maximum call combine. This is combine. If max is less than max 1, right, then max is equal to max 1. As max man is greater than man 1, then man is equal to man 1. Right? This is how the algorithm is maximum I comma j maximum min. Alright, here are some indexes. So we only provide indexes. Alright. So here is no extra space we use. So there is no extra space we use in this global array. Parameters I and j are integers. One is the effect of is to set max and min to the largest and smallest value of in commas respectively. If I is equal to j, then max is equal to min ai, alright, small. Then else if I is equal to j minus 1, then another else case some of a small p, right? So if ai is less than aj, then max is aj, minimum is ai. Else max is ai, minimum is aj. Else if p is not too small, divide p into subproblems, find by state I plus a by 2 mid, solve the subproblems, max min I mid max min, max min mid plus 1 j max 1 min, min, right? So from what? If max is less than max 1, then max is equal to max 1. If min is greater than min 1, then min is min 1. Right? Combine is the after returning these, right? These are some combination, right? So performance of department max, number of element comparisons. Let tree of n represents number of elements fn in any element, right? So tree of n is equal to 0, n is equal to 1, it's 1 when n is equal to 2, right? 2 of tn by 2 plus 2, right? So to I have 2 n by 2. So and n by 2 n by 2. This is 2 is combination for all that. Yeah. So after with substitution method, what we can say this. I, alright. Power k and I have to keep k plus 1 here minus 2. Why minus 2? We'll figure it out. Alright. So this is n by 2, 2 into 2 to the power k, right? Minus 2 equal to n by 2, 2 to the power k is equal to 2, right? Plus 1. So k I is equal to 1 to k 2 to r I is this. This is the case. Alright. So this is a. So when I is equal to the k is equal to n by 2. N by 2 here. I 2 n by 2, then to power 2k right? Minus 2 by 2 plus n minus 2. This is how we do that. So if n is equal to 3n by 2, I think, right? 3n by 2. Number of element completes all cases, right? 3n by 2 minus 2. So divide and conquer here, increasing order will be what? Non-decreasing order, divide and conquer. N minus 1, this is 3n by 2. 3n by 2, 3n by 2 in all cases. 2n minus 5, 3n minus 1. Random order. This is random order here. So space complexity would be what? Order of 1, order of log n. So always be inject trade-off between space and time. Alright. Thank you so much guys, and we'll meet you in the next one. Live. Thank you so much.